Hi guys, welcome to my channel. In this video we are going to analyze a question is about the structural analysis. The question will be analyzed due to moment distribution method. In this question there is a sideway, so there is a displacement. We are going to calculate by displacements to find the fixed and moments. So let's find the stiffness factors and solve the question. For stiffness factors dA, it ends with pin, so I'm going to use modified formula 3EI over 6, 0.5 EI. Stiffness factors for DC, 4EI over a length. What is length? Length is here, we are going to find it. This is 6, this is 8 feet. Okay, this is also 6 feet. 6 and 8, this is going to be 10 feet from geometry, you know it. And this is KCB, okay. 3EI again, because we are going to use a modified formula like I said before. Over 12, 0.25 EI. Now I have stiffness factors. Let's find the distribution factors. DFDA equal to 0.5 over 0.5 plus 0.4 will be equal to 5 over 9. And when I subtract from the 9, okay, I'm going to obtain 4 over 9 equal to distribution factor DC. And distribution factor CD also will be equal to 0.4 over 0.4 plus 0.25 will be equal to 8 over 13, and 1 minus 8 over 13 will be equal to 5 over 13 equal to distribution factor CB. And now I have my own distribution factors. Let's write it its own place. And this is 1 because it is pin. This is also 1. And this is 5 over 9. This is 4 over 9. This is 8 over 13. This is 5 over 13. Okay. Now I write the distribution factors. Let's find the fixed and moments. In this question, you can see there is a sideway and there is no any normal force that we calculate the fixed and moment. So we are going to just calculate from the deflection. Okay. So for the deflection, what was the formula? You can see I wrote the formula here for you. I put it the picture. So I'm going to assume a deflection from the dA. Then I'm going to obtain the delta prime from the dA. But deflection will be the same. For example, the deflection will be at this direction because the force acts at here. And for example, this is going to be delta. And this is also will be delta prime. Okay. And now it's going to be equal to 3I delta prime over LDA square. Okay. I'm going to take it as equal to 100. This is just an assume. And then this 100 is positive because in this direction, if this direction is positive, it is reverse, it is negative. Okay. This L is 6 square. When I multiply with 100 and divide it with 3, delta will be equal to, delta prime will be equal to 1200 over EI. Now I have my delta, so I'm going to write this equation, this formula for CB, and I'm going to put the delta prime in its own place, and I'm going to obtain its fixed and moment. Okay, so let's do it. This will be also 3 EI delta prime over L CB square, okay? CB square. Oh, sorry, this is going to be CB. CB square, okay? From this formula, 3 EI multiplied with 1200 over EI. This EI will cancel each other. And I'm going to divide with 12 square. And this 12, it comes from this length, okay? And this will be equal to 25. Keeps to fit. And this is also 100, keeps to fit, okay? So now, let's write this here its own place. For DA, the fixed end moment will be 100. Okay, we will do 100 because I use here. And for CB will be 25. I also obtained it here. Now I have fixed end moments. I don't have any fixed end moment here. Here 0, 0, and also 0. And now I'm going to distribute its own, the rate of its own distribution factors. So I'm going to 100 multiplied 5 over 9 and take the negative of that. It's going to be minus 55.56, okay? And this is also be minus 44.44. I'm going to take 100 multiplied with 5 over 9 and take the negative of this value will be equal to minus 55.56. The process is like that, okay? So for this one also, 25 multiplied with 5 over 13, take the negative of this value will be minus 9.62, and this will be minus 15.38. It is right. And now there is 0 because the fixed end moment here is 0. And I'm going to carry over this value here. But I cannot just make the carryover here because why? Because I use the modified formula. This will be closed. This will be closed and I can't use it. 1 second, I have a problem with this table. Yeah, now it is okay. Now it is okay. But something will be confused. Sorry, I'm going to write here. Let's continue. I can't make any carryover at this direction because I use a modified formula and this is closed for me. For now here, I'm just going to make a carryover at this both direction. Okay, this will be minus the half of this value will come here, minus 22.22, and this will be minus 7.69. Okay, and I'm going to distribute this moment at this ratio. Okay, when I distribute this moment, minus 7.69 multiplied with 5 over 9 and take the negative of this value will be 4.27. And this will be 3.42. And this moment, when I distribute at this ratio, it is on, for example, for CD, it's going to multiply with its own distribution factor and take the negative of this value. So it's going to be equal to 13.67 and 8.55. And this both will be carried over to each other. And this is going to be, take the half of this value is 6.84 and 1.71. And I'm going to again distribute this moment at this rate, this both ratio, and take the negative of the value, minus 3.8, minus 3.04, and 1.71. This moment I'm going to distribute at this ratio, and this will be equal to minus 1.05 and minus 0.66. Okay. And again, I am going to make a carryover. Half of this value will come here, and it's going to be minus 0.53. And this is going to be minus 1.52. And I'm going to distribute this value at this amount, at this ratio. Okay. And of course, take the negative of that. This is going to be 0.29. This is going to be 0.24. And this moment will be distributed at this ratio and take the negative of the value, 0.94 and 0.58, and make a carryover. When I made a carryover, and it's going to be 0.47, 0.12, and I'm going to, of course, share at this for this one, this for this distribution. I'm going to multiply with 5/9 and take the negative of that, and I'm going to obtain minus 0.26. Okay, and this will work also minus 0.21. I'm going to write them a little faster because you understand how it's going to be. And now I obtain, so let's calculate the moments. Okay, I'm going to write a moment here. Total moments here will be equal to 44.96 and minus 44.96 and minus 23.84 and 23.84. Okay, this is the moments that I obtain. Now I have the moments, so let's find the shears. I'm going to obtain the shear and then calculate the last moment that I need. Okay. To obtain the shear, I'm going to lie down the columns. This is A and this is D. I have a moment, 44.96. I don't have any force here also. If this at this direction, we are going to write here, this is going to be at this direction. Total moment at D is equal to 0. This direction is positive, minus 44 point, sorry. 96 plus A VA multiplied with this length is 6, okay, and this length is 6 equal to 0, VA equal to 7.493. And let's find for the second part. For the second part, it is C, and this is B. Okay, 1 second. We're going to write here as B, and this is C. At this direction, this is 23.84, and there is a B here as the shear. So total moment at C is equal to 0, and this direction is positive, minus 23.84 and plus VB multiplied with 12 equal to 0. VB will be equal to 1987. You know, we had an R and R prime normally to calculate the last moment that we need. So how it was something like that: AX plus, okay, AX plus BX plus R prime equal to 0 for this one. But now I have AX and BX, okay, and R prime is equal to 7.493 plus 1987, and R prime will be equal to 9.48. For the first R, you know, we have an R over R prime equal to C. We use it like that, and R will be that force it acts, because there is no any other force, and there is no any normally we use the first table and we use truth table. The first table was, we assume that there is no any displacement, okay, so we can't use that table now, so we're going to take as R3. R will be equal to 3 gives, okay. Now I have R and then R prime, so let's calculate the last moments that I need. So moment dA will be equal to 9.48 multiplied with 44.96 and equal to 14.2 gives fit. And for moment DC will be equal to 3 over 9.48 multiplied with minus 44.96 equal to minus 14.2 gives fit. And for moment CD, 3 over 9.48 multiplied with minus 23.84 equal to 7.54 give fit, okay. For moment CB, 1 second to write it better, 3 over 9.48 multiplied with 23.84 equal to minus, excuse me, this will be equal to negative, and this will be negative, this will be positive. .54 keeps fit. Now we find the moments. The last moment are these, okay. We need these moments, so we obtain the moments. The question is that, thank you for watching me. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did something wrong, please comment. I'm going to check whether I can revise or I can fix or not, okay. I'm going to make the videos better. Thank you for watching me. See you for the next question.